Hi everyone, my name is Kaitlyn Tran.
And I'm Michelle Wang. For our project, we chose to analyze visitor traffic in national parks and the factors that surround visitation. Our reasoning for choosing this topic is twofold. One, we came across articles stating that the national park system recorded record-breaking attendance levels last year. While reading more on the topic, we noticed that some parks remain consistently more popular than others, which piqued our curiosity about factors that may affect park attendance. And two, while researching the national park system, we read several reports about how air quality and pollution levels in many national parks rival those of major cities. We wanted to see if there was any correlation between these elevated attendance levels and elevated pollution levels. We found the traffic dataset through irma.mps.gov, which hosts data about national parks. After doing a bit of digging on the website, we came across this dataset. While researching our topic, one of the first resources we consulted was the National Park System Wikipedia page, which contains a table of data on all the national parks. We took the acreage data from this table.
So the National Parks API was the first resource we found that we could use for the project, and we found it through the official National Parks website. We saw that there was a lot of useful information provided, and since you could search by park by inputting a park code into the API URL, we decided that we were capable of parsing it, so we chose to use that. Another reason why we chose to use this API was because it provided us with a documentation that showed what parameters you could put in to get specific information about each park. Like here the documentation shows that if you put in ACAD, which is the park code for Acadia National Park, you can get information about Acadia's campgrounds. Lastly, we added on an ozone dataset after phase 1 because we decided that we wanted to have a sort of environmental factor to compare our data against. And we found this dataset when we were looking at articles about how ozone levels in national parks were slowly increasing over time. And one of them linked to this dataset folder on the National Parks Data Store website. Each Excel file in this folder showed the number of ozone exceedance days for each park in recent years.
After reading in the traffic data using the read CSV method, we used the group by function to check for any duplicate or missing data. We then treated the inconsistencies using pandas methods such as replace, drop duplicates, and append. After returning the Beautiful Soup object, we used Beautiful Soup's findAll function to isolate the data we wanted, and used for loops to put the data into lists for easier manipulation. However, there was unnecessary data mixed into the acreage data, so we deep copied the list containing acreage and used a for loop and the list remove function to iterate over the list to remove unwanted data.
The API had a much larger variety of parks than the downloaded dataset, so we narrowed our search in API down to a specific list. First, we passed in the general parks parameter into the URL to get the entrance fee and entrance pass prices. We used the same processes to get the state that each park was in and its latitude and longitude. Both processes utilized dictionary indexing. Next, we passed in the campgrounds parameter into the API URL to get the number of campgrounds, each park's average campground price, and whether or not there's a trash recycling collection system in place at each of their campgrounds. There were some anomalies in the data, like Haleakala National Park didn't have any campground info, so for cases like that, we just filled the output in with no data. Given 7 different Excel files that all varied slightly in the parks that were included, we had to find a way to combine all of them. So we did this by creating a loop that iterated through a list of the Excel files. And some of the parks had multiple ozone detection areas, so each loop grouped the data frame by park code and then it summed up the columns. This made each park have only one row for each Excel file.
Since many national parks also serve as nature preserves, we wanted to know if a larger acreage would correspond to higher traffic counts. We read in data from the clean traffic dataset and the acreage dataset. then merged and sorted the data by traffic count. Upon inspection of the output data frame, we found that there is no correlation between traffic and acreage. In addition, the linear regression line for this data has a slope close to 0, indicating that there is essentially no correlation. Although this outcome did not align with our initial hypothesis, it makes sense. While there are researchers who work in these national parks, they are very much a minority subset of the traffic data, and as such would not affect traffic counts by a significant amount. People go to national parks for recreation. Since camping is a popular activity and also one of the few activities every park offers, we wanted to see if the number of campgrounds and possibly the cost of campgrounds would influence traffic count. We read in data from the clean traffic dataset and the cleaned API dataset, dropped the necessary columns from the API dataset, then merged and sorted the data by traffic count. The linear regression line had a slope of 816, essentially creating a vertical line. As such, we found no correlation between traffic, number of campgrounds, and the cost of campgrounds. While unexpected, this conclusion makes sense as this data does not take into consideration other factors that would affect campground usage, such as the quality and climate of these campgrounds.
For this insight, we were wondering, would increased visitor activity and subsequent automobile emissions contribute to ozone exceedance days? Ozone exceedance days are just days that are measured to be higher than the National Ambient Air Quality Standard for ozone. So after analyzing our data, we saw that the most common month for there to be an ozone exceedance day was in the months of May, June, and July. This corresponded with the highest traffic days being in the months of June, July, and August, so these are both in the summer months. We were able to conclude that there is a positive correlation between exceedance days and park visitation. This is probably due to the high number of visitors causing unnaturally high numbers of air pollution to both industrial and automobile emissions. For example, a visitor that travels by car and stops at amenities like restrooms, shops, or restaurants, those all contribute to higher concentrations of ozone. Prior to analyzing our data, we thought that higher entrance fees would deter visitors and lower entrance fees would encourage more visitors to come. But after we analyzed the data frame, we saw that the most expensive parks had lower visitation, which was on par with our prediction, but the parks with the cheapest entrance passes had relatively low numbers, which was kind of unexpected. So we can kind of conclude that the park visitation and entrance fees don't necessarily cause one another, but there are cases that show how they complement each other in ways to promote economic income. More specifically, some parks are more expensive because they have lower visitation numbers, and so they increase prices to make up for less visitors spending money there. And parks with average prices have a usually high visitation as they're closest to a sort of equilibrium where they don't need to make their prices really high or really low. For our last insight, we compared the number of ozone exceedance days over time within the years 2013 to 2019. And unfortunately, as one would predict, we did observe increasing trends over time. The majority of the parks showed that as time went on, the number of ozone exceedance days slowly but steadily increased. Thus, there did appear to be a positive correlation between time and ozone exceedance levels.
As seen in this line graph, there is a steady rise in visitation from 2013 to 2016, and then a dip in 2016 to 2017. However, there is still an overall trend of increasing traffic. This graph serves as a supplement to some of our insights. As shown in this graph, the peak months for visitation occur during the summer, when vacation season is in full swing. Likewise, this graph also serves as a supplement to some of our insights.
For this visual, we chose to use Joshua Tree National Park as it had the most amount of ozone exceedance days in 2013, meaning that we could more easily spot a possible trend. And as you can see, there is a slight correlation. As visitor numbers go up, the number of ozone exceedance days went up as well. For this one, we graphed 16 different parks that had at least 3 valid data points for each of the parks. And you can see that even just over a period of 7 years, there has been a rise in ozone levels. And one of the things we thought was most interesting was that you can see a spike in 2018 This was most likely due to the California wildfires because most of the parks that spiked were all on the West Coast. Also, if you compare this graph to traffic by year, you can see that the two actually relate to each other, and that the steady increase in traffic is the same as the steady increase in ozone levels over the same years. So to sum it all up, a few of our original hypotheses, like that there would be strong and visible correlations between traffic and acreage or between traffic and fees, those weren't all entirely correct. But we did find and see some interesting things with the correlations between things like ozone levels versus time and entrance fees versus traffic. So overall, we think that while the results of our project weren't exactly groundbreaking, the fact that the data is accurate and taken from legitimate sources means that they are valuable for answering any questions one might have on the topic of national parks. Hope you enjoyed.